Welcome back! Today we are joined by Professor Corsandi. He'll be taking us through critical synergy between cloud architecture and digital defense.
This is a discussion on cybersecurity and cloud computing, and specifically how cloud computing vendors or cloud providers leverage cybersecurity in supporting their offerings. Just a quick rundown of what we discussed last time out. I mentioned to you that in this title slide that you're seeing on the screen, we're essentially depicting what cloud is all about. The promise of the cloud is essentially our end users can leverage any device, whether it's on a phone, mobile phone, laptops, desktops, tablets, or even servers that you have on your premises, communicate and connect with the resources that are running in the cloud and the resources that we consume in the cloud. That's the consumption model that we were talking about. And then we'll discuss three different as-a-service models: infrastructure as a service, platform as a service, and application as a service, which essentially deals with whether you need to only provide the infrastructure for your application and your development needs, whether you're subscribing to a platform such as databases, SQL servers, Java virtual machines, runtime environments, etc., to test and develop your applications. And finally, when the entire application stack, everything from the bottom all the way up to the top from infrastructure, is all provided as well. We went through what the definition of cloud computing was and is, based on what NIST has given. We spoke about the computing paradigm shift. And again, I'm giving you just a rundown of last time. That's why I'm quickly going through these slides until we start to the main topic of tonight. We mentioned that because cloud computing provides services, the way they charge for their services is based on the way utility companies provide, and you pay as you go. And this is very attractive in terms of the expenses that a company faces, which is typically done operational expenditures, which means you can realize those expenditures immediately, and they're very predictable as opposed to CapEx, where you have to put that money up front. We spoke about the four different ways of deploying cloud models: public, private, hybrid, and community. We mentioned that public is the most common one that currently runs in the industry. We then spoke about hybrid cloud is the one that's probably the one that most of the companies are interested in, because certain services, due to regulatory requirements, they cannot run in the cloud. And certain services might have to run on their premises in their own data centers. And we said that in terms of figuring out which one is the appropriate model, it all depends on your business requirements. We then broke down the characteristics of private clouds and public cloud. Private cloud is run on by internal resources. And the main reason we're interested in private cloud is because of privacy and security. And then we compared what's the difference between traditional data center and private cloud. And we said the main difference between them is really the mix of the applications that you want and how quickly you want to be able to run these environments, whether you're whether you have elasticity and scalability in your solution. We then spoke about the 5 traits of the cloud as National Institute of Standards and Technologies defined them. These are 5 critical ones, regardless of whose cloud computing training you take. These are the 5 unique requirements and key characteristics of any cloud provider. The fact that you subscribe to a service that's considered self-service, which means anybody who subscribes to them can actually go there and build and create them without the need of somebody helping you over the phone or somebody assisting you to set those services up. The fact that the services are up 24/7 from anywhere across the globe. The fact that you can pool the various resources, compute resources, CPU, RAM, disk, network interface card, anything else, applications across various geographies. That as your needs increase, end of the month, end of the year, you need to have additional capacity. Elasticity exists in the services that the cloud providers give you. And we spoke about the pay-per-use or pay-as-you-go model as well. We then talk about some additional infrastructure terms, such as infrastructure modernization, cloud providers, scalability. We spent some time talking about a number of various industry regulations, and these are important. And in fact, we might come back to some of these again later tonight. We then talk about why do we want to consider leveraging cloud services. We spoke about the various terms such as HAFT, discussed the differences between them, scalability and elasticity. And in fact, all of these terms, if you take ever a certification exam for cloud providers, whether it's Microsoft's, whether it's Google's, whether it's Amazon's, you're expected to know these terms that are captured in slide 14. We then went through and break down the difference between high availability and fault tolerance. And we said the fault tolerance essentially is for really very high demanding applications that require major complexity, and they cannot afford even a small brief downtime. We then talked about some of the challenges that involves in multi-tenancy, which come around with public cloud. We spoke about the fact that we have to ensure that our tenants are isolated. We need to make sure that as additional workloads are added on these servers that are hosting multiple tenants, that the performance of these VMs will not suffer as a result of that. There is sufficient capacity in there. We want to make sure that multi-tenancy can take advantage of provisioning of additional host capacity. So for example, tomorrow, if I need to add an additional 4 gigabytes of RAM to one of my virtual machines that are running in the cloud, we want to make sure that this does not create any problems. We also talked about the fact that it's very important, it's critical that the hypervisor, which is the layer that the abstract layer that runs below the application, below the virtual machines and above the hardware, is not compromised, because if it is compromised, an attack on the VMs is going to ensue. And we also mentioned that essentially the security requirements of each virtual machine is the same way that you apply security to physical machines. We spoke about the approach of defense in depth, which is means including multiple layers of security. We then briefly touched upon virtual private clouds, which is an instance of cloud that is dedicated and allocated to a tenant. We spoke about the importance of software-defined networking, and the reason for that is it essentially allows you to separate the control plane from the data plane, and you can listen to all of these in the previous recording that was posted. We then spoke about the importance of encapsulation, similar to using a VLAN, except that in cloud, because of the number of clients that a cloud provider supports, we now use VXLANs. And the fact that every virtual machine, every tenant will be using a software firewall, which is a stateful firewall, which keeps track of the connections. We call that virtual firewalls. And then we spoke about how cloud providers ensure that data is not leaked between virtual machines that are belonging to different tenants. Remember, on the same server, we host different VMs. One VM could be client A, one VM could be client B. That's why we want to make sure that there is no leakage of memory or leakage of content. That's why it's very important that when a VM is terminated, these cloud providers go through and zero out the physical RAM. This is almost like the way when you want to dispose of the hard drives on a machine that you no longer need. There are companies that actually go there and double write on a particular drive or format it and then or apply some kind of magnet. It's the same concept in here to make sure that the data is no longer accessible. We spoke about the differences between VLANs and VXLANs. We spoke about what's the difference, what difference VXLAN brings to the table. The fact that instead of having to deal with only 4,000 VLANs, you can have up to 16 million VXLANs. And the fact that instead of broadcasting, we use multicasting. And then we spoke about the importance of network virtualization. Remember, in the cloud, most, if not all of the things that clients, tenants will experience will be a virtual instance, which means a software representation of a real component. We then spoke about each virtual machine having two IP addresses, whether a customer address or provider address. And again, the IaaS, PaaS, and SaaS are the three major cloud service models, which we call it as a service model. We then briefly touched upon the shared responsibility model. It's not just the cloud provider is responsible to provide the infrastructure security, data center security, making sure they have eyes on who's accessing the data center, who's able to walk in, making sure that the presence of a cloud is not very obvious to the outside people. And then we spoke about the importance of the client keeping track of the data, making sure they're responsible for the security of their data, that they handle which endpoints access the services that are offered in the cloud, as well as handling identity access management, who can log on, who can access, and what level of privilege we need to give them. And then I shared with you a chart that Microsoft provides in terms of what the division of responsibility is. And as you see on this slide, slide 26, information, data, devices, and accounts are always maintained by the customer. And that's why you see they're all in dark blue, which pertains to the customer responsibility. And that brings us to today's session. So the focus that we're going to have for the remainder of tonight deals with security. And why do I bring up focus on security? Because this is the number one concern for tenants and clients. In order to address security properly, an international standard has been designed by major providers, by major organizations, and that's called ISO 27017. It's a code of practice. It's an international standard. And essentially, it talks about what security controls, what security guidelines cloud providers must abide by. And essentially, these are considered to be commonly accepted protection controls. In addition, what's very important is that this is not only something that is considered to be best practice. Major cloud providers like AWS, like Azure, Google Cloud Play, Oracle, IBM, they even certify against this. That means they go through all the specific items that are listed in this code of practice, and they make sure that their environment abides by them. What are some of the important areas that this code of practice talks about? Let's go through them. We already spoke about the shared roles and responsibility. What this document says is that as much as it is the cloud provider's responsibility to provide the infrastructure, provide the applications, provide the computing environment, it's also, as you just heard, it's the responsibility of the client to properly handle the security of their data, authentication, who gains access to their data. The next thing that is captured here in this code of practice, in this international code of practice, I should say, deals with what's going to happen if a customer no longer wants to subscribe to the services that this client has, and they essentially want to terminate their contract. Essentially, what needs to be captured here is that what assets that belong to a customer are going to be returned back to them upon contract termination. If they certify against this, that means they're actually doing it to make sure that no security issues arise from this. A very important topic that we already spoke about and touched upon last time is how do we segregate this particular tenant, this particular client from other tenants. We spoke about making sure data does not leak from one to another, and we're going to have to talk about some more of that the rest of tonight. You've heard in your IT courses, in your other computer science courses, about hardening requirements. This is the fundamentals of any cybersecurity. Hardening requirement essentially means removing unnecessary services, disabling unnecessary accounts. Any application that we do not need anymore needs to be disabled or uninstalled so that we reduce the attack surface. And VM hardening requirements are not any different. Think about it, with VM is a software representation of a physical machine. And VM, which essentially simulates or emulates what a physical machine is no different as far as hardening requirements to improve the security. Another item that's captured in this code of practice deals with how administration is going to be done, and particularly what level of access or what high level access rights the cloud provider has to your machines. So this administrative operation, in terms of there are certain updates that the cloud provider provides that we cannot do. For example, updates to the base operating system. We don't touch that. That's something that the cloud provider does. So these procedures are all captured in this code of practice. Something that's very important is for every client, especially if they're going to be subject to auditing, and especially they're going to be subject to regulations, they need to be able to monitor whatever activity is going on within their own specific computing environment. So this code of practice spells out how that's going to be done. And we spoke about the physical network, which is all the machines, cabling, servers, and networking that the cloud provider gives you. And virtual network is what essentially is represented to us as an abstraction of that physical layer. And it means in terms of how are we going to align the security for these two different environments for our clients. So this is a very important standards that cloud providers have actually certified for. Last time I briefly talked about slide 29, so I started to add some more content in here. You notice in this particular slide, I'm talking about what organizations are interested in, what do they look for when they try to evaluate cloud service providers. One is security assurance. And you notice the NIST as well as ISO has various documents. The purpose of security assurance is to say that if there is any claim or that the cloud provider has about their security, can these be validated? Can they provide evidence or not? And that's what I mean by security assurance. Another one is called privacy assurance. Privacy assurance essentially means that how does the cloud service provider handle personally identifiable information? You know, certain regulations are, particularly in GDPR in European Union, are very high in terms of how is the data handled? Who is handling it? Does the customer that owns that data, that the data belongs to, know who is handling it and when is it being sent and who is it being shared with? Privacy assurance also deals with ethical standards. What ethical standards do you follow? And specifically, we spoke about data sovereignty, which is where does the data reside, and how is the data being replicated from one to the other, or is it even being replicated depending on what countries we're operating, how the data is being used, and how is it actually being controlled. Another evaluation criteria is called operational transparency. Transparency is a very important thing. Customers want to know, do we have visibility into what's the actual behavior that the cloud provider can give us? And of course, up to the point that they don't reveal too much about their infrastructure because they don't want to give that information out to the hand of hackers. Another example, it deals with data governance clarity. And you notice each one of these has a separate document. So data governance means how do we perform governance? How do we categorize the data? How do we control the data? How do we protect the data during its entire life cycle? Entire life cycle could be at the end when we no longer need this data. Maybe this data has to be archived or possibly data has to be deleted. So this entire process, this entire governance is captured through this data governance clarity. We spoke at length last time about regulations. So there are also how do the operations of these cloud service providers align with the various regulations? I included the gold standard that our federal government uses. It's called FedRAMP. FedRAMP is actually an abbreviation for Federal Risk and Authorization Management Program. This is considered to be, in fact, a security gold standard, at least in the US. And this is essentially, it tries to touch on how do you perform security assessment? How do you handle authorization? How do we continuously monitor the cloud for their various operations as well as services? And finally, how can we actually verify a lot of these things independently? You know, organizations have their books audited by a third party, and this cloud is no different. There has to be some independent audit of internal controls and the reports being available to the public, to the cloud tenants. So you notice organizations have to be aware on their toes for 6 very important considerations when they try to evaluate cloud service providers. So along the same lines, NIST, again, NIST, for those who might have forgotten, it's an agency within the United States Department of Commerce, and they are the organization that establishes all the policies, standards for the United States government agencies. They're completely vendor neutral. And in fact, they published several different articles and white papers regarding cybersecurity as well as cloud computing. So they mentioned that you should carefully plan the security and privacy aspect of your cloud before you engage with any cloud providers, particularly in the public cloud, as we're talking about. Remember, you're going to be storing your data. You're going to be consuming services that are actually going to be operated by a third party. So it's very important to make sure you understand what are the security and privacy protections that they will be able to provide you. And as we spoke about the fact that we are sharing infrastructure, whether it's server, networks, etc., with other tenants, that can actually run in conflict with how traditional data centers used to operate. So it's very important to make sure we understand what policies the cloud providers have, what procedures they have in place, and what technical controls they have to secure as well as reduce the risk for operations. So it's very important to understand and require that any cloud solution meets the company's privacy, security, and other requirements as well. In fact, based on the regulations that a client is subjected to, such as FERPA, if you're a higher level university, Sarbanes-Oxley for almost all the different companies, HIPAA in the health industry, you need to be aware whether the cloud solution that you're subscribing to, does it meet these requirements or not? If not, then you might have to go back and evaluate another cloud provider. So we talked about the term sovereignty. Sovereignty is a very important terminology from privacy and security perspective. It essentially is a concept that talks about the data that we store from our systems, which we call a digital format, has to be subject to the country where that data is located. You might say, so what's the big deal about this? You know, we're in an interconnected world, in a world where organizations spread across the globe. A company might have offices not only in the United States, they definitely have offices in the European Union, might have offices in any other continents as well. So each country has various privacy laws. Each country has various regulations. The regulations that are in place in European Union are different than the one that's in the United States. And now you start to deploy cloud solutions. This makes it a little bit more challenging. I briefly hinted at the idea of 2 specific countries, China and Germany. The reason I picked these 2 countries is because these 2 countries have special legislations already in place. Any company that tries to operate, whether cloud or non-cloud, and are not familiar with how data retention is going to be done in these countries, they will be subject to a lot of penalties. And essentially what they say is that, let's say This company has branches in Germany, United States, and China. And let's say they're using email or file processing, folders, files, any application. I'll just give you two examples. You are not allowed to replicate the data that resides in Germany to the United States. This is against the idea of data sovereignty in these two countries. And that's why it says here, it requires customer data to be kept within the country. And that's why you need to be aware of the laws within that country and how you should keep the data. So in order to be able to be compliant with data sovereignty, as a security professional, you must know, where is the data stored? Is the data being replicated? Are we backing up the data from one country to another? And some organizations, they might do that, but that means that the data sovereignty rules are not as strict as China and Germany. Not only that, at the end of the day, who can access the data? Can somebody from country A access data in country B? And also another thing, how is data encrypted? It used to be that certain encryption technology could not be exported from United States. So you need to be very careful. Like, for example, if you take your laptop with you and you're traveling to a foreign country, and that foreign country might not be necessarily recognized by United States Department of State, you could be in violation. And unfortunately, you could face prosecution. So you need to be very careful about where your data is going to go. And this applies to the cloud as well. And through the answering of these four very important questions, you essentially come up with what's called a governance strategy, meaning how do we address data sovereignty concerns? At the end of the day, ladies and gentlemen, we need to remember that the responsibility to meet data regulation falls on the company that owns the data, as well as the cloud provider that provides the data storage services, if they are providing data storage services. So both of them have to work hand in hand. In the next 3 slides, I'm going to talk about some general guidelines or what we call best practices for implementing cloud security. First and foremost, as you probably have heard in some other courses as well as some other lectures, before you even start to do anything, before you start to work on a keyboard or a mouse or making any changes, you must establish a security program. You must implement it and you must also maintain it. And as you do this, your end users need to be trained on this and they need to be certified on this. They need to be aware and understand what it is. And that means that security program needs to be written in a language that your end users that might not necessarily be technical can understand what it is all about. The second best practice guideline deals with building a secure cloud infrastructure. Secure cloud is end-to-end essentially. We spoke about some of these items already. Hardening the host servers. That means we remove all the unnecessary servers, only the base software that is required, the hypervisor and whatever else is needed to support that hypervisor. It goes without saying that confidentiality is quite important. Confidentiality of the data that you're storing. Confidentiality essentially is synonymous with encryption. And for those who might not know what encryption is, we're talking about applying some kind of a mathematical algorithm, an encryption formula to plain text and creating what's called ciphertext. And only if you have access to the keys that perform this encryption will you be able to decrypt it. It goes without saying that once the data is protected and once it's unencrypted, we want to make sure who can gain access to that data. Who can log on and gain access to data, and that deals with IDA, Identity and Access Management. We spoke about zero trust. Only provide the bare minimum permissions for the users to gain access, hence the term access control. There needs to be provisioning process for both the environment as well as the applications. How do we provision applications? Who's going to be responsible for that? What's the process? What change management we need to go through? How do we go through testing phase? How do we go through approval for a process? There also needs to be a vulnerability and intrusion management program. What do I mean by that? You know, when we deal with cybersecurity, we also always have to be aware of where could potentially vulnerabilities exist. There might be some vulnerabilities we might not be aware of. There might be a zero-day virus that we're impacted by. So what do we do in that situation? Do we have intrusion protection system or intrusion detection systems where we can take actions thanks to AI technology, such as machine learning, understand what the attack is, perhaps isolate that system, or perhaps shut down the interfaces so our systems will not be compromised any further? And last but not least, in order to implement a secure cloud, you need to make sure continuously test, continuously valid, not just a one time before you actually go online and go live, but this needs to be continuously in your bloodstream, essentially. And in fact, if you look at these 8 or 9 principles, they're not that different as if you were operating in a non-cloud environment, which means if you're running a traditional data center, you still have to do this. So cloud essentially follows on the same footsteps, except that a lot of things in cloud are going to be virtualized. We already spoke about end users should be educated, and typically a lot of organizations go through either once or twice a year training where they have to go there and certify and maybe even take a test to understand, hey, do I understand what is involved with security? Are my users security aware? First rule of thumb is that every organization has to come up with security policies. Security policies have to be explained in a language that your end users can understand. Security policies have to say, where can we store the data? Can this data be stored on USBs? Can the store be on an internal storage? Can it be stored in the cloud? Who can gain access to it? Which is what's considered to be access control lists. And the purpose behind the access control list, which follows the security policies, who can access it, during what time can they access it? Also, as part of these security policies, the organization has to spell out what are the consequences if we store our organizational data in the cloud where we have not authorized it. So all of these need to be captured, and that's why this security policy is a very important document. So when we deal with security, when we deal with encryption, you have to work with keys, whether there's going to be symmetric key or asymmetric keys. This slide 34, talks about the concept of key management. If you want to maintain CIA, confidentiality, integrity, and authentication in a cloud environment, you need to understand what cryptography I need to do and how to handle the keys that support cryptography. Number one, it's very important for everybody to understand if a key is lost, if a key is compromised, if it falls in the wrong hands, it can have serious consequences. The very first thing you got to do, you got to go to revoke that key, start all over again, which could add cost as well as time and slow down your processes. When we deal with key management, we're not only talking about how you produce a key, we also have to talk about how you distribute this key, how you transmit it from one side to the other, where do you actually store it, and how do you actually destroy it. This is the entire life cycle, as we call it here, entire process. Everything needs to be spelled out. Now, if you store keys on a storage device that is not is considered to be a non-cryptographic device, then that key has to be stored in an encrypted fashion itself. Remember, the key is the key to your environment. So you got to keep it very secret. Not only that, because the key is so important and carries so much value, you need to make sure you have backup copies of it available and stored in a safe location. Where can I store it? In Microsoft Azure, there is something that's called Key Vault. The Key Vault actually safeguards all these cryptographic keys as well as any secrets that are stored. In fact, even though it is hosted in an Azure cloud, Microsoft has no access to it. It's only you and only you that can access and open it. Related to Azure Key Vault, there's also, for those workloads that have high compliance requirement, there's something called Azure Key Vault Managed Hardware Security Module. In AWS, it's called Key Management Service. And the term Key Management Service pertains to storing digital encryption keys. Now, as you're probably aware, there are two types of encryption that you generally perform, symmetric or asymmetric. And this digital encryption keys addresses both of them. Another example of what AWS does is called AWS Secret Manager. And this Secrets Manager essentially stores application level secrets. What are application level secrets? API keys, keys related to application programming interfaces, credentials that pertain to databases, and databases themselves support applications, as well as secure shell private keys. Secure shell essentially is an encrypted way of performing telnet to remote servers. Also, it's very important to try to limit the number of keys. The more keys you have, the more sophistication you create, the more complexity you create, and the more management overhead you create. And not to mention the fact that the cost goes up. Also, keys should be sufficient length. If the keys are too small, they can easily be broken into, they can easily be guessed. So we have two examples. The gold standard across the globe for symmetric encryption, where the two parties share the same key, is called AES 256. And as the term implies, that means the size of the key is 256 bit. In fact, the United States government uses AES 256. If you're dealing with asymmetric encryption, where you have two keys or a pair of keys, public and private, you either use RSA or the more industrial strength, which is called ECC. ECC stands essentially for elliptic curve cryptography, which means the data that you're talking about are actually residing on an elliptic curve. Whereas RSA has 2048 and 4096, 2K and 4K. ECC, because it's much more efficient, uses either 256-bit or 384-bit. By the way, because of the overhead that's associated with asymmetric encryption, when you're trying to encrypt large files or files that require a lot of processing, you use symmetric encryption. Symmetric encryption typically has less overhead compared to asymmetric. You're only dealing with one key, not a pair of keys. What about cloud services for government? In this case, I'm only dealing right now with the US government. All cloud providers, whether it's Microsoft, whether it's Amazon, whether it's Google or IBM, which are essentially the top four providers, provide separate cloud services for government. Microsoft calls them their offering Azure Government. This is essentially the Microsoft's trusted cloud for US government agencies. So what's so special about this? The special thing about Azure Government is the fact that it is completely isolated physically. That means it doesn't share any infrastructure with the rest of the public cloud for other public or other agencies, other organizations. It is also logically separated. It's also legally separated. And not only that, it's built for the US government. So it meets the US government's high security standards. On the other hand, AWS provides services for over 7,500 government agencies. And they provide cloud capability for these many agencies. By the way, AWS is the number one in terms of cloud provider. And as I understand, they have a market share of somewhere around 30% of the overall cloud market. And apparently Azure is not far behind, around 25% or so. Within AWS, there are over 200 services that run that are specialized public mission across various classification level. Classification level, we're talking about confidential, super confidential, registered confidential, internal use only, etc. And what the government agencies typically use is called AWS Gov Cloud. And you typically break it down either on a US East or US West, and that's about all you're going to learn about it. They don't give you the locations purposely. Now, these are obviously all similar to Azure government, completely isolated, both physically as well as logically. And they're only operated by US citizens because that's a requirement of US government. By the same token, Google Cloud GCP supports our civilian agencies in the US. They also support intelligence community as well as DoD, Department of Defense, Pentagon. And IBM Cloud also supports all the major government standards as well as helping the agencies to move their applications into the cloud. So you notice the four major players in the cloud, in addition to Oracle Cloud as well as Oracle Cloud, also support this as well. My understanding is that because Alibaba who's also one of the leading providers, because they're mostly a Chinese company, my understanding is that they do not provide a cloud service for government. These four companies are obviously all United States based. The next to last topic we're going to be talking about deals with IoT, Internet of Things. Why are we talking about that in the context of cloud computing and cybersecurity? First of all, let's get some definitions out of the way. When we deal with IoT or the Internet of Things, we are talking about connecting these physical objects, the physical objects that we use every day, to the Internet, and be able to capture valuable information from them. What kind of devices are we talking about? It could be your refrigerator, your coffee machine, and more seriously, your medical devices and even smart devices. When we talk about medical devices, this could actually have life-impacting events, life-impacting devices. Why are we talking about IoT? Is because these devices are online capable, which means we can access valuable information from them. And this information, in fact, can also be relayed for data analysis. And these IoT devices produce tremendous amount of information. So what does IoT actually pertain to? It actually refers to any physical device that has some kind of a circuit board. In that circuit board, we have sensors attached. So what is a sensor? Sensor is really a hardware component. Its job is to detect a physical input. What's an example of a physical input? Maybe it's heat, maybe it's pressure, and takes that heat or pressure and translates it into something binary, something digital signal. What's an example? Maybe we have a smart thermostat within a particular area. This smart thermostat can receive data from your car while you're actually commuting. And you might have a thermostat that can adjust your home temperature before you actually arrive based on your interaction with it. And sometimes you might not even have to intervene at all. So to even manually adjust a thermostat. So the point in here is these IoT devices, which are physical devices, they have typically a circuit board, like a circuit board that a PC or a laptop has, like the one that a mobile phone has. And they are able to receive and transfer data over Wi-Fi network. And the key thing in here is with limited human intervention. So obviously that means that these IoT systems are going to be continuously sending and receiving data. And we go through and analyze this data. It's called a feedback loop, almost like a way our processing cycle is for application development. from when the concept comes in, when we continue to receive feedback from everybody, and try to understand what this data means. And in 2026, in the age of AI, we can leverage AI as well as machine learning. Machine learning is one of the specific workloads of AI to understand this data much better, learn from the past, be able to predict the future, try to predict patterns of data, what this data means over a short time period or perhaps even a longer period of time. Here's an example, a practical example. Maybe I need to predict what is the optimal time to control the thermostat before I arrive home. I'm coming from work. Maybe it's middle of winter, particularly in the Northeast. I need to make sure the home is warm enough. During the day, I turn the temperature down. So my IoT system could connect to the Google Maps API, application program interface. Or maybe you could even find out what's the real-time traffic. So why would you do that? Because you can see when I might be able to get home. So we capture all this data, and through this data that is collected, we will be able to figure out, okay, when would this thermostat be able to go up so that the house is warm enough and we don't overspend on heating the house. That's just one example. So telemetry obviously plays a major role here. Every one of these IoT devices we spoke about, excuse me, they send a lot of data from their sensors. They send it back to the cloud. Where else? Why in the cloud? Because remember, in cloud, we said that you have scalability in terms of storage. And this data, which we call it big data, which in terms of terabytes or petabytes of data, would be ideal to store in the cloud. Telemetry actually refers to a continuous stream of status. As if you look at the actual data, it becomes tremendously difficult to process using traditional techniques. So some examples I want to share with you, some practical examples. You could have a mobile refrigeration truck. And what it does, it sends the temperature every 5 minutes to an IoT hub so you can analyze and see, hey, is this refrigerator truck operating? Do we need to take corrective action? Maybe there is a backend service that's going to be sending a command to a device. That device can be anything. Or maybe a device that is going to send alerts based on the values that it reads. What's an example? Maybe a device in a chemical factory, chemical plant. There is a reactor, batch reactor. Ingredients are being mixed inside a chemical tank. If the temperature exceeds a certain value, maybe it would be undesirable. So that device can actually send telemetry over through its sensors to some centralized location. We could have also all devices send information to be displayed on a dashboard to a human being. And the human being then would be able to take appropriate action. So what they can do, they could take a look at what's the temperature, what's the pressure, what's the flow. These are the critical measures in any factory floor. So in an IoT solution, what does the backend provide? The backend service is the service that actually receives the telemetry from our various devices. They can receive this telemetry at scale. At scale means we're able to capture as much data as possible because we're storing the cloud. We can analyze the telemetry through AI. And through AI, we can gain insight in terms of what this data means in real time, or maybe even afterwards, maybe for future purposes. It's possible we want to be interested in terms of sending a command from the cloud to a specific device so that maybe they shut down the device or do something about that device or make some changes to it. Provisioning your device and controlling which device can actually connect to your infrastructure. So this would be a measure of a security, in fact, as well as controlling what's the state of my devices, monitoring what their activities are in real time. So and these actually, each one of these things produce some kind of a log files that gets reported to that backend device. And as you know, as you're familiar with, like the same way we do with the PCs and servers, when every once in a while the BIOS has to be flashed or the microcode has to be updated on a router. We can also manage the firmware that's installed on these devices. Remember, firmware is a microcode, a low-level machine code. And this firmware gets every once in a while updated by the manufacturer. So IoT is of particular interest from consumers. I'll give you some examples of it, like a coffee machine, like a refrigerator, etc., or even a wearable smartwatch. But privacy and security are going to be top major issues with everybody. And the second issue is the fact of the volume of data that these systems produce. Because there's tremendous amount of data, we call this thing big data. First of all, big data, as the term implies, deal with not just terabytes, but even petabytes of data. And you cannot process this data using traditional techniques. So that means there's got to be more up-to-date technology, such as what cloud provides, as well as AI, to take advantage and try to gain insight into that data. So how do we handle IoT security? Hackers can actually compromise any IoT solution. And the first thing they do is try to figure out what are the weaknesses on these various devices that we have built. So it's very important to make sure that security is built into every part of our IoT solution. If it's not built into every part, we're introducing major risks. And remember, this could actually reveal a lot about our environment, which is something that a hacker can actually use to conduct reconnaissance about your environment. And this could impact our reputation. And as we mentioned, IoT security is a major consideration. And the challenges are, how do you perform data analysis? How do you capture the data? How do you search for the data? Where are you going to store this data? Who do you share it with? And how do you take care of data privacy? And the top two cloud providers, Azure and AWS, they have essentially capabilities to provide security as well as control for every part of the IoT solution. What do? They monitor the health of these IoT devices. If a device is compromised, they can block any of those compromised devices. They can also find threats that could be impacting these devices and eliminate them based on importance that they assign to them. One example is in AWS, they have something called IoT Device Defender. Again, as I mentioned to you, it uses artificial intelligence, specifically machine learning. And through that, they can identify, here's an example. Identify a smart toaster that's sitting in Ohio. All of a sudden, we notice that it's trying to connect from an IP address that's in a different country. Oh. Or maybe it's trying to, a sensor that is sending 1 kilobyte of data. All of a sudden, it tries to send gigabytes of data. So maybe there is a data exfiltration. Or maybe a device is trying to communicate to command and control center, like the way a centralized bot is going to control other bots, other compromised machines. What does Microsoft do? Microsoft has an offering called Microsoft IoT Central. It's a SaaS solution, software as a service. It's fully managed by Microsoft and essentially allows you to not only connect, but manage and monitor your IoT devices. In addition to what we just talked about, IoT Device Defender as well as IoT Central, these cloud providers also provide you with configuration suggestions. Configuration suggestion would be what is considered to be best practices from that cloud provider's perspective to improve the security posture of those IoT devices. And my last slide for tonight, and we finally reached the end, is if you're wondering first of all, I went quickly because I want to make sure that we take advantage of the time that we have. If you're interested to learn more about any of these relevant technologies, such as cybersecurity, such as cloud computing, or the combination of both, I've listed 3 courses in SCAS, which is our undergraduate program in Torah, as well as 3 courses in Graduate School of Technology, beginning with Fundamentals of Cloud Computing. For the moment, this course is an elective course, but it's about to change and is supposed to become a mandatory core course for those graduating with a computer science degree. The next one is GCON 231, which is Fundamentals of Cybersecurity. This is also considered to be a core course. And usually they take this in the beginning of the 3rd year of their program. And also GCON 325, which is Advanced Cybersecurity, which is typically taken in the senior year. In the Graduate School of Technology, a course that I teach myself is Advanced Cybersecurity and Internet Technologies. And a couple of major discussion points in that course are cloud computing, firewalls, and a lot of things that we touched upon in this lecture, in this presentation. And there are also 2 elective courses. One is called Secure Virtualization Technologies, because remember, cloud leverages virtualization significantly, as well as Architecting Cloud Solutions in Azure. So anybody's interested, there are these options available at your disposal. I want to thank everybody for attending this presentation. I hope this presentation and the one before this proved useful to you. I will provide the updated slide content, send it to our organizers, who will then be sharing it with you. Thank you so much for your time and attention, and I wish you much success.